In the previous session, we have studied about Karnaugh map of sum of product. I will quickly revise some of the concepts. So we studied about the definition of Karnaugh map. It's an array of cells in which each cell represents a binary value. Okay, we studied about 3-variable Karnaugh map, how to draw it. Then we studied about 4-variable Karnaugh map and how to draw it, right? Then we mapped the expression in the Karnaugh map. Fine. This is a mapping of expression on Karnaugh map for a 4-variable. Fine. We also found that if the expression is not a standard SOP expression, standard sum of product expression, then we have to convert it into standard sum of product expression. Most of the times, this situation may not arise. Okay. Okay. So if the expression is not a standard SOP expression, then you need to make it a standard SOP expression, right? And then you map the expression on the Karnaugh map. Fine. Just like this, a 4-variable non-standard SOP expression is converted into standard SOP expression, right? After that, we studied about the simplification of Karnaugh map. How do we do the simplification? So we combine variables, that is ones in case of SOP. We combine them, make them a pair. There may be one group. There may be a group of 2, we call it pair. There may be a group of 4, we make it a quad, or there may be a group of 8 or even 16, right? It is always in the power of 2. In the Karnaugh map, there may be a wrap around adjacency. We have already studied about the wrap around adjacency because we assume that this and this, they are adjacent. The first row and the last row are adjacent. Similarly, the first column and the last column may also be adjacent. So in that case also we find the wrap around adjacency. Fine. So this is the wrap around adjacency. It's an octal, 4 here and 4 here. Fine. Then we simplified Karnaugh maps for a 4-variable here, right? Now today we will talk about the POS expression. Before that, we studied about the don't care condition. So I have already explained that sometimes the situation arises in which some input variable combinations are not allowed, or even if they are there, we don't care. Okay, we do not consider them. So such a situation is called don't care terms. For example, in a BCD code, BCD stands for binary coded decimal. We will study about that later. It's a binary coded decimal. Okay, it's a BCD. In case of BCD, right? So we have a situation like this. There is a binary code which we convert it into hexadecimal, I mean. So this is the binary code. 0000 means 0. It's a decimal number. Basically, it's a decimal number, right? So 0001, so it's 1. 0010 is 2. 0011 is 3. 0100 is 4. 0101 is 5. 0110 is 6. 0111 is 7. 1000 is 8. 1001 is 9. Up to this point, it is fine. Humans can interpret the decimal code easily because we have studied about decimal number systems, right? but the computer operates on binary number system, right? So when it comes to binary and you combine multiple bits like 4-bit here, right? So that makes an hexadecimal system. That makes a hexadecimal system, right? Now, if we combine 4 bits and only represent decimal, that becomes BCD. In case of BCD, this codes 1010, 1011, 1100, 1101, 1110, and 1111. They stand for this hexadecimal equivalent. In case of hexadecimal equivalent, they are A, B, C, D, E, and F. Okay. Now, these codes are not included in BCD, so we call them invalid code. So in case of BCD, codes related to A, B, C, D, E, F, they are called invalid code. Okay. BCD, again, I'm telling you, BCD is a binary coded decimal, and it is used to represent the decimal numbers using hexadecimal system or the binary system. Fine. So I hope you got the point, right? So we can consider them, this one, into don't care condition. That means if they exist, it should not make any difference in the circuit, right? Okay. So where do you see this don't care, and what do you do with don't care? So for example, this X, they are for 1010, 1011, 1100. For that, we have put X, 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 and X. 6 X's are there. Fine. There are 6 X's, 6 don't care condition. Okay. Now, if we write 1 here, let's say, so it is A bar B C D. Okay. So we write 1 here. So then this 2 will make pair. Now X means it can take any value, 1 or 0. Understand? The meaning of X or don't care, in case of don't care, you can take 1 or 0, any value. Okay, whichever suits you. So here we are taking 1 here, 1, 1, 1, 1, 1, 1. Because if we use 1, then we will be able to reduce the expression. Fine. So that is 1, 1. So without X, it's only 1 here and 1, 1 here, right? But with X, with don't care condition, your expression is simplified to A plus BCD, which was earlier A B bar C bar plus A bar BCD. Now, what you need to learn from here, that if there is an X or a don't care condition, then you should consider it. For example, here is X and here is 1. Then you should consider this one as a pair. Understand? Or in fact, it's a wrapper out adjacency. So 2 here and 2 here will combine. So do you have any question related to this? Anybody has any question? Okay, no question. Fine. Now, how to map a product of some expression on a Karnaugh map? Okay. So Here, if we have an expression like this, a plus b plus c, this one, a plus b plus c, a plus b plus c bar, a plus b bar plus c, a plus b bar plus c bar, and a bar plus b bar plus c bar. Fine. Okay. Now, remember, in case of this is bar. So I'm going to write the whole bar here. Okay. So in case of POS, you will take A as 0 and A bar as 1. Okay. POS is in a way is just the opposite of SOP. Understand? POS is exactly the opposite of SOP. For example, and you can transform one into another. For example, you have A plus B. This is one, and second is A plus B bar. This is another one. So this can be simplified as A into A, of course, plus A into B bar. Okay. Then again A into B, that is AB, plus B into B bar. A into A will become A plus A into B bar plus A into B, and this will become 0. This will become A, right? Okay, now what you can do, A into, combine this one, 1 plus B bar plus A into B. Yeah, this is A into 1 plus B bar. 1 plus B bar is, it's 1. This is 1. Okay. And AB is AB anyway. So this is A into 1 plus AB. This is equal to A. Okay. Plus AB. Now I take A common. Once again, 1 plus B. So that gives you A, because 1 plus B is equal to 1. Again, 1 plus any variable in Boolean algebra, it is equal to 1. So now finally you get A. Okay, now what does this suggest? That if there is A plus B and there is A plus B bar, it should be simplified as A. So B and B bar will cancel out. Understand? Understand this?
Yes, sir.
Okay. Fine. So here, this is actually 1 for it. Okay. But in case of POS, this will stand for 0. This will stand for 0. So 0 plus 0 will give you 0. And this stands for 0 and this stands for 1. So 0 plus 1 will give you 1. Fine. Okay. Okay. There is a question from Abhishek Singh. How? What you are referring? Okay. Step number 3 in A is equal to 1. This one. You're talking about this one, right? This is A into 1, not A equal to 1. 1 plus B bar. That is because 1 plus B bar is equal to 1. We have already studied that 1 ORed with any other variable will give you 1. So for example, there is A, there is B. A is 1 and B is 0. What will be A plus B? It will be 1. If A is 1 and B is 1, what will be the answer? 1. So that means if any one of the input is 1, then the output will always be 1 if we are going to 1 plus do anything with here, whether it is B or whether it is B bar. Understand? Okay. Okay. Second, when you are doing like this, now there might be a question that why 0, right? So if you see A, B and A plus B, then if A is 0, B is 0, then you get 0 here. If for any other case, you will get 1, right? So we consider this one as the only combination. That means if 0 plus 0 is there, then only we will get 0. Otherwise, we will get 1, 1, 1, right? So this is considered as A. This is considered as B. Fine. This is exactly the opposite of sum of product, right? In case of sum of product, you have A into B. This is A into B. So 0, 0 will give you 0. 0, 1 will also give you 0. 1, 0 will give you 0. 1, 1 will only give you 1, right? So we call it A into B. Fine. Okay. Now let's get back to our discussion of POS. So in case of POS, this is A plus B. This is A plus B bar. This is A bar plus B bar. And this is A bar plus B. Okay. And this is C. This is C bar. So naturally, this will be A plus B plus C. This will be A plus B plus C bar. This will be A plus B bar plus C. A plus B bar plus C bar. A bar plus B bar plus C. A bar plus B bar plus C bar. A bar plus B plus C. And A bar plus B plus C bar. So POS is written like this. Okay. Okay. Now you have one expression here. A plus B plus C. That means there will be 0 here. A plus B plus C bar. That means there will be 0 here also. Then A plus B bar plus C. It will be 0 here. A plus B bar plus C bar. That means there is a 0 here also. And then we have A bar plus B bar plus C. That is 0 here. Okay. Remaining terms are not present. So you can leave them blank. Understand? Remaining terms are not present. You can leave them blank. So you need to put 0 there. Okay. Now all of you, please draw this. Write the expression and draw it. I hope you are doing it. I will give you 3 to 4 minutes to finish this task. Okay, fine. I think you have done it. Okay, fine. So if you say this, then it's A, and A. Right? All four combinations of A are covered, right? A plus B plus C, A plus B plus C bar, A plus B bar plus C, and A plus B bar plus C bar. Okay. So if you try to simplify this expression, right? A plus B plus C plus A plus B plus C bar plus A plus B bar plus C plus A plus B bar plus C bar, right? Now what we will do, we will take this one, this is 0, this is 0, and this is 0. So this will make one quad. It's a group of 4. Okay. Do you see any other group here? Okay. Where is it? You can unmute yourself and tell me, where do you see any other group?
सर 0 1 और 1 1 का 2 ग्रुप बना सकते हैं ना?
Yes, exactly. So there is a group here also. It's a group of 2. We can call it a pair. Right? Now, A plus B plus C, A plus B plus C bar, A plus B bar plus C, and A plus B bar plus C bar. So this together, here look at this, B bar, right? And this is, sorry, just a minute. Okay. This is A plus B, and this is A plus B bar. Here we have C, and here we have C bar. So C and C bar both are covered. That means they will be eliminated. And B and B bar both are covered. So that will be eliminated. So now you have A. Okay. You are left with A. Understand my point? Similarly, here you have A bar plus B bar, and this is C actually. So it's a C here. So that means it is A bar plus B bar plus C. That is this one. And here it is A plus B bar plus C. So this pair, I'm referring this pair. Okay. And I will solve this pair in our whiteboard. Okay. So it is like this. It is A plus B bar plus C. And then it is A bar plus B bar plus C. It is like this. Understand? So now we can take B bar plus C common. Okay. Fine. So we can take A into B bar plus C. So what I'm doing, I'm actually dividing this into a group A plus a group of B bar plus C. Then you have A bar plus a group of B bar plus C. Now you can multiply this two. So it will be B bar plus C into A plus B bar plus C into B bar plus C. Okay. Okay. Plus it is A bar into B bar plus C, plus it is A into A bar. So this one is reduced to 0. This is in itself B bar plus C. The reason is that A plus A is always equal to A. Okay. So B bar plus C plus B bar plus C will give you B bar plus C. Here it is multiplied with A. Here it is multiplied with A bar. So now you have B bar plus C, that is coming from here, plus B bar plus C into A plus A bar. Now A plus A bar is nothing but 1. So finally the answer is B bar plus C. That means if you see one variable and its complement both are covered, then those variables will be eliminated and we are left with this only. Understand? Okay. See what I have done. I have multiplied A with A bar. Then I multiply A with B bar plus C. Understand? After that, I multiplied B bar plus C with A bar. And then I multiply B bar plus C with B bar plus C. So there will be 4 terms. Understand? So this is the first term of multiplication. Here B bar plus C and B bar plus C are multiplied. Here A bar into B bar plus C. So that is A bar into B bar plus C. That is third term, this one, right? And then you have A into A bar. Now A into A bar is 0. B bar plus C into B bar plus C. So that is like A into A. Now A into A is always A, and A plus A is also always A. Remember, these two are very, very important. Similarly, A dot 0 is 0, right? A dot 1 is always A. So these are some identities, right? We know that. So A bar into B bar plus C. B bar plus C into B bar plus C will give you B bar plus C. B bar plus C into A. Now I'm not expanding that term, remember. And here also it is A bar into B bar plus C. So what I will do out of this term, that is 1 number, and out of this term 2 number, I will take B bar plus C common. So it will become A into A plus A bar. Now A plus A bar is always 1. So now once again you are left with B bar plus C plus B bar plus C. Right? So that means it is a single B bar plus C. So you don't need to simplify this every time, but what you need to understand is that if there is a variable and its complement both present, then you can eliminate it. And that's the purpose of simplification using Karnaugh map. So you get B bar plus C as another variable. Okay. So as a result, finally, we will have an answer, that is A. And here it is, from this pair, you will get B bar plus C. Okay. This is A, this is B bar plus C. So finally, you have an answer, A into B bar plus C. That is your answer. Right? Have you written this? Have you finished writing, everybody? Okay. So let's go to next problem. Okay. Now try to understand this relationship between SOP and POS. Here you had A, B, and C variables, and from this quad you got A, and from this quad you got B bar plus C. So final answer was A into B bar plus C. Now instead of zero, suppose you put 1, 1, and 1, right? So from from POS we write 0. And as I said, the SOP is exactly the opposite of POS. So wherever you are putting 0, instead of 0, if you put 1 there, and then you consider them as an SOP, right? Then also you will get the same answer. So here you will get A into B bar plus A into C, right? Understand? Now that is the purpose of writing 0. Okay. That POS is exactly the opposite of SOP. Do you see this? So I hope this concept of POS is clear in your mind. Anybody has a question? Anybody has a question here? No. Okay. Now, next problem is B plus C plus D, A plus B plus C bar plus. So it's basically a 4 variable Karnaugh map. It is basically a 4 variable K-map. Fine. But as I said, each expression must be converted into first the standard POS expression, right? So first you need to convert it into standard expression. So for example, B plus C plus D, if it is given like this, then you should consider A and A bar both. That means it will be A plus B plus C plus D. And then you have A bar plus B plus C plus D. Okay. So look at this. So the first term is expanded. Other terms are kept as it is. Fine. So now the final equation is like this. A plus B plus C plus D. A bar plus B plus C plus D. A plus B plus C bar plus D. A bar plus B plus C plus D bar. A plus B bar plus C plus D bar. A bar plus B bar plus C plus D. And in case of K map, you can express them like this. So it's 0. Remember, this is A plus B. This is A plus B bar. This is A bar plus B bar. And this is A bar plus B. Similarly, this is C plus D. This is C plus D bar. This is C bar plus D bar. And here it is C bar plus D. Okay. Now try to look at all the terms. A plus B plus C plus D. So that is here. So you put 0 there. Then, sorry. Then A bar plus B plus C plus D. So where is A bar plus B? Here. Plus C plus D. So it's 0 here. So we have written 2 zeros here. Then A plus B plus C bar plus D. A plus B plus C bar plus D. So we write 0 here. Then A bar plus B plus C plus D bar. Okay. So A bar plus B plus C plus D bar, that is 0 here. Then A plus B bar, C plus D bar. So A plus B bar, C plus D. Sorry, I think there must be some. There must be something wrong, or there is something wrong in the expression. A plus B bar, that is here. C plus D. This should be 0. This should be 0. So it is A plus B bar plus C plus D. It is A plus B bar plus C plus D. Okay. It is not C plus D bar, but it is C plus D. So there is a correction here. Okay. So now everything is put into the place. Fine. We have 0, 0, 0, 0, 0 and 0 here. Fine. Now we make a group of 4, another group of 2, and of course we have a wraparound adjacency there. Right. So this way we make 3 groups. Okay. Just draw it. Okay, so you have time to draw. So draw it. Okay. So we formed a group of 4, a group of 2 like this, and a wraparound adjacency also, right? With a group of 2. So what happens? This group entirely, it is C plus D. It is once again, it is C plus D bar. This is C bar plus D bar. And here you have C bar plus D. Similarly, it is A plus B, A bar plus B bar. Here it is A bar plus B. And then you have A plus B bar, right? So this is a group of 4. It covers all the combinations of A and A bar, B and B bar. So it is A plus B, A bar plus B, A bar plus B bar, and A plus B bar. So that means you have C plus D as an output of that group. Understand? Okay. Then here and here, what is common? So basically, A plus B bar is always common in this group, right? And C is there. D and D bar, these are 2 combinations which are covered, right? So basically we have equation like this: A plus B bar plus C plus D, and A plus B bar plus C plus D bar. So if you see, then D plus D bar, as I said, the variable and its complemented form, these both are covered. So that means that variable will be eliminated, and then you will get A plus B bar plus C. And that's the reason you see A plus B bar plus C here. Understand this? I hope you understand this. Here also, you have A plus B plus C plus D, that is first term. And the second term is A plus B plus C bar plus D. Okay. So A plus B and A plus B are common, D and D are common, C is and its complemented form. So this is the variable which is changing. So variable and its complemented form both are covered. So we will eliminate that variable and we will get A plus B plus D. Do you understand this, or anybody has any question related to this simplification? Okay. See, if you have a doubt, you should clear it right now. Okay. Now this is the problem that you are supposed to do. So let's do it. Okay, so it's a very simple one. I think you can draw and simply solve it. A plus B plus C, A bar plus B bar plus C, and A plus B bar plus C. So how will you solve this? First, you need to draw the Karnaugh map as always. Right. So this is A plus B. So 0, 0, 0, 1, 1, 1, 1, 0, and 0 and 1. So it's going to be A plus B bar, then A bar plus B bar, and then A bar plus B. Okay, so A plus B plus C, that means it is 0 here. A bar plus B bar plus C bar, so it's 0 here. And A plus B bar plus C, so 0 here. Let's see. Right? So 0 here, 0 here, and 0 here. Okay, now how do you simplify this expression? Right? So now how you can solve this? Group here, that's it. It's very simple, right? And here you have A plus B plus C and A plus B bar plus C. So A plus B plus C and A plus B bar plus C. So which variable is changing? B bar is changing. Eliminated. You are left with A plus C, and the second term will be as it is. A plus B, A bar plus B bar plus C bar. So it will be as it is. This is your answer. Okay. So once you practice it, it is very easy. Yeah. Once you practice it, it is very easy to solve the expression using Karnaugh map. Right? This is probably the last session for Karnaugh map. From coming sessions, I will talk about the different combinational circuits like adder, subtractor.
हेलो सर,
Yes.
एक प्रीवियस स्लाइड करो तो एक सेकंड. Okay, okay.
Okay, now you can enter your enrollment numbers, all of you, for the attendance.